So I was assigned problem number 24 on homework 3, which reads, what is the electric potential at the point indicated with the dot in figure 28.24 as shown here? So to find the electric potential at the dot, you have to find electric potential from each individual charge. I labeled this charge 1, charge 2, and charge 3 here. So you have to find individual electric potentials from each charge acting at the point to get a electric potential net, I called it. And that is, again, just the sum of the individual electric potentials acting at the point. To do that, the general equation for an electric potential is the constant K multiplied by the charge Q divided by a distance R. So for this instance, I just did the individual electric potentials corresponding to the charge. So electric potential 1 is corresponding to charge 1, electric potential 2 is corresponding to charge 2, and electric potential 3 is corresponding to charge 3 here. So solving them individually, for electric potential 1, it's given that the charge is 2 nanocoulombs, which can be converted to 2 times 10 to the negative 9 coulombs. And R is a distance of 3 centimeters, which can be converted into 0.03 meters here. Plugging them into the equation here, I didn't bother writing out K since K is just a constant. But yeah, plugging those values into the equation here and calculating it, we get 599 volts for electric potential 1. Doing the same for electric potential 2, the charge is, as you can see, the same. The only difference is the distance, which is 4 centimeters instead of 3 earlier. But it's the same idea, plugging in the correct variables. So instead of dividing by 0.03 meters this time, we're dividing by 0.04 meters. And in doing so, we get 449.5 volts. Lastly, for 3, the charge is 4 nanocoulombs, but the distance is 5 centimeters. And I got 5 centimeters by doing this. I know that between charge 3 and the point is a diagonal line, which would form a right triangle in the shape of this. And I know the 2 legs of the triangles are 4 centimeters and the horizontal distance would be 3 centimeters. And through Pythagorean theorem, I calculated this hypotenuse of the triangle to be 5 centimeters. Given that, we now know the R distance to be 5 centimeters or 0.05 meters. So once again, we're plugging and chugging and solving electric potential 3 to be 719.2 volts. Now to find the total or net electric potential at the point, you simply just add the 3 electric potentials together and you end up with a value of 1767.7 volts. Thanks.